Okay, so hello, I'm Void. In this video, we are going to dive deep into coding UEFI application using EDK2. Before we start, I want to say that you need a good understanding of C programming. I won't be teaching C here. I will focus entirely on UEFI development with EDK2 from scratch. If you know C, you are already halfway there. So let's get started. First thing first, what is EDK2? EDK2 stands for EFI Development Kit version 2, and it was originally created by Intel, but now it's not just Intel anymore. It's now maintained by the UEFI community. Like, it's an official open source reference implementations. EDK2 is a development framework. It means that EDK2 provides everything you need to write, build, and test the UEFI applications and the drivers and the firmware modules and much more things. EDK2 gives us a build system. This sets of tools and scripts that take your C code and turn it to a UEFI application. UEFI header files, UEFI libraries, example firmware codes, like things like that. Okay then, now let's get EDK2 and then we can start coding. I will use Ubuntu VM, but okay. First, I will delete this and new folder called UEFI. So I will delete this too. I will do it from scratch. That I will have here source. I will share these comments with you. So you need to install these things before that. We need to get the EDK2. You need to sudo apt update and then install these things all. Yeah, they are installed to me. So I will use a terminal. Oh, sorry. Close. So I will just git clone to EDK2 from GitHub. I will share these comments with you in the description or the comments. After this, I will share the DCG file and UEFI.in file that are these things are the custom of UEFI application. Like we are building by these things. This inf and DCG is the maybe most important thing. Okay, now it's installed. We need to get the submodules. Okay, it didn't work. Ah, sorry. Okay, as you can see in here, these things are not like in the EDK2, so we will just install them by like this. Now our environment is ready for coding. Next, we will create our first UEFI application as simple Hello World program that prints Hello UEFI to the screen. This will be our first step into UEFI development, and from here we will gradually explore more advanced topics like boot service, runtime service, memory maps, and even driver developments. Now I will copy these things on. Okay. So okay then, let's go through our Hello World UEFI application. I will say it in our main.c. Then first we need to include at the top of the file, I will say includes uefi.h. I will explain them all, don't worry. I'm just writing them and then I'm going to explain all of them. If you would service table lab.h. Okay, so the first one, UEFI.h, is the main header file that defines the fundamental UEFI types and macros. It gives us things like EFI status, which is return type of most UEFI function, like think of the return 0 in C. So we'll use that for EFI status, which is the return time type of most EFI function. EFI handle we have, which represents handles to objects or application, and EFI system table struct, which contains pointers to all the service we need. Next, we include UEFI lib.h. This library provides helper functions for UEFI application. The most important one for this example is print function, which allows us to display text on the screen without writing low-level code or for console. Like console output is part of the EDK2 library system, making our life much easier. Then third includes UEFI boot services table-lib.h. It gives us access to the boot service table. Boot service includes functions like memory allocation, timers, and protocols that we might need later. For a simple Hello World, we don't use them directly yet, but including this header, it's a good habit because mostly real UEFI programs will need boot service. Moving on, we define the entry pointer of our application now is if is status because we will say return 0 like think like C. Then FI API is the heart of UEFI, so I will explain all of them. So we have UEFI main in here. We had an integer main in C. Now in EDK2 we have UEFI main. Then I will say in FI handle, image handle. Then in FI system table. Okay, now UEFI main is the standard entry point for all UEFI applications. The return type FI status is 64-bit integer that indicates success or failure, returning FI success or FI error, FI buffer small, and things like that. FI success means that application executed correctly, otherwise like FI load error indicate errors. So FI API is the heart of UEFI. FI API is calling convention macro. UEFI has a specific way function must be called at the firmware level, and this ensures compatibility with the UEFI firmware. The first parameter, the FI handle, image handle, as you can see in here. So image handle is a unique handle provided by the UEFI firmware representing this instead of our application. You can think of its like reference to our program. The second parameter system table, as you can see here, and it's a pointer. So it's a pointer to the main system table. This table is central UEFI programming because it gives us access to console output, boot service, and runtime service. Using this system table, we can interact with the firmware in a standardized way. So inside the function body, we have a single line. Where's my cursor? Okay. So we have a just one line that's saying print L hello EFI. Now here we call the print function like from EFI Notice the L before the string. This marks its wide character string, which is required because EFI uses Unicode internally. Regularly, it's ASCII strings but in UEFI, ASCII strings won't work reliably in UEFI. So we are just going to new line. Then finally, we will say return FE success. So finally, return FE success. This tells the UEFI firmware that our application finished successfully. If we wanted to signal an error, we could return a different status code. In summary, this simple program demonstrates the basic struct of UEFI application in EDK2. We include headers for types, libraries, and services. We define UEFI main as the entry points with the correct parameters and calling convention. We use print to display text, taking care to use Unicode string. We return if it's success to indicate success. Even though this program is very simple, it lays the foundation, and for more advanced application from here, we can explore boot service, runtime service, memory management, and more things. Understanding this Hello World program, it's the first critical step in learning UEFI development with EDK2. Now I will save it and exit. Then I will just come to source and clear the screen. So we need to say, like, we need to make this base tools because we need GANFIV or other things. You can ask what's a GANFIV. GANFIV is like, it's when you have a DLL thing, it's just compiling it to a .f file. Now I will say source, then I will say build, and we will build it. Now it's done. We will just we can close this and come here. As you can see, there's an UEFI app.fe. So I will put this in here. I can delete this. Then open a terminal. So first thing first, we need to look that OVMF is created. Yeah, as you can see. Then I will say if you boot because the QEMU and BIOS and UEFI looks if you boot 64 first. I will copy UEFI app to UEFI boot and boot 64.fe and copy this file in here. Then for the like running our program, I will use this. Now it will be so fast, and as you can see, we can't even see that, and it's done. Now we need to do something about it. So we can do this. So there's something called GBS. I will explain it later. It's some pointer, so we are accessing to this, and there's something called stall. Stall is just a sleep function in C, like it's just sleeping for like when we say 3. So it's just going to sleep 3 seconds. It's some microseconds, so we need to say 3 like this. If you want it 4 seconds, 5 seconds, 6 seconds. But I will say 4 seconds is enough. So I will come to source again. And do this. Oh, sorry. Now, okay, it's done. Then we can just close this and come here and copy the EFI file in here. Delete this file, we don't need it anymore. Now copy. We don't need to copy this, and then we can just do it again. And yes, you can see there's an Hello UEFI GTL key. I will exit. As you can see, it says Hello UEFI from there. So well done. It's your first Hello World program that you did on BIOS UEFI shell. So thanks for watching. If you have any questions or like things, you can ask in the comments.